Welcome back to the Facit Homes channel, and welcome back to our new series Facit Builds as we follow our latest project, the Walton house, from concept to completion. In this episode, episode 2, we're going to be talking about everything that happens once you've got planning, going through the technical design stages, all the way through to getting ready to actually send information to our Microfactory and putting shovels in the ground for the foundations. So we're going to start in the studio and talk through with Bruce this whole stages, the BIM model, and also we'll talk to Pedro about the production side of things.
So the biggest task at stage 4 is the detailed work it takes to create the BIM model. Our BIM models are more accurate and more detailed than you might find in a traditional architecture practice, where for us, the BIM model is everything. We're actually leveraging that through our manufacturing process. So we'll spend more time, more resource making a very accurate 3D computer model than you would typically find in a traditional architecture practice. So in the design work we do prior to planning permission, we will have already signed off all the exterior of the building. So the window, the cladding, the big stuff. At stage 4, in terms of client engagement, we're signing off the interior. So the floor finishes, the paint colors, the taps, the kitchen, all of those choices that the customer needs to make. So we spend time with the customers getting those things agreed with them. Some of those things might go beyond us starting on site, but we'll have all the budgets allowed for all of that in advance. So in terms of specification for the interior, customers have a very wide range of choices to make. We help them through that process. They might say, hey, I'm interested in using this particular brand or this particular tap or this particular flooring. Our job is to guide them through that process and say, you know what, this is not the good enough quality, but yeah, this is good and we think this is going to work well for you. Or even just making sure it's consistent as well. You know, if they want to go for a black metal theme for fixtures and finishes, we make sure that we're getting all of those and we've not got half of the fixtures in black and half of them in chrome, you know, that we're there as designers to bring their ideas to life and make sure that they're really consistent.
So as Bruce mentioned, one of the key stages once we come out of planning is really developing the BIM model. So a BIM model is essentially a 3D model. It stands for your building information model, and it simply means it's a 3D model, but that model is packed full of all the information that we need to actually build the house. So a wall is not simply just a box, it has the buildup of the wall. We can pull out of it how much insulation is in the wall, and most importantly for us, we know exactly how many sheets of plywood that we have in the model. We've modeled up in our BIM software, which is Revit, all of the components, right? So each one of these components is parametric, which means it's not modular in that it's fixed to a specific size. These modules can adapt to any size, which is what enables us to build any shape or size of house. Each of these components tells us exactly how many sheets of plywood it needs to make that component, and therefore we know exactly how many sheets of plywood it's going to take to actually build your home, which along with all the other things that we can cost means at this stage of the project we can cost your house incredibly accurately. We know exactly how many things we need to order and the quantities, and this is really one of the benefits of the BIM model. The other aspect is it's also a design side as well. So as the model becomes richer and richer with more detailed information, we can walk the client through, again using tools like Enscape, to walk through your house pretty much in the equivalent of a digital twin of your house. So you can get a feel for the spaces, you can actually start to feel what it might be like to be in your house, and also see all the details that you might not see in the 2D drawings that you view. We've also been experimenting recently with uploading our model onto the cloud securely so no one else can see it, but we can share it specifically with the people on the site as we move into the construction stages. They have access to the model as well through their computer, but with the online viewer, we can also view it through an iPad or a phone, and we can increase that communication between here in the office and on the site, and also connect the real world, which is actually building things, with the digital world. And that's why we're always going back between the virtual and the real. So architects will typically also use BIM, but probably not to the same level that we do. Firstly, we model down almost to the nuts and bolts, which means this is what enables us to cost things down to such a high degree of accuracy. So typically in a traditional process, an architect would kind of model it, but more from a design perspective. They may have some build-ups and things like that, so they get primitive quantities, but they won't know the actual way that it's going to be built. And then on the other end of the spectrum, a traditional contractor would probably not have a BIM model at all. They'd probably just look at the drawings, and we kind of fuse those together. So our model is for design purposes, but it's also for construction purposes as well. And again, that's one of the advantages that we have as a design and build firm. This is the BIM model of the projects. As you can see in this stage, it's like very detailed. We have everything from the exterior into the interior. And from this model, we're doing, three-dimensional stuff, but we're also creating detailed drawings. So these will be used for coordinating different services within the project. In this case, this is setting out the foundation system. So we're creating 2D and 3D information at the same time. You can see here, we've actually got a BIM model of the entire chassis. So this is what I was explaining earlier, where every single component that we have within our building system is modeled in our software here, and it is what's called parametric. So this component here is not necessarily a fixed size. You can change, for example, the corner depth from 250 to 500, and you can see it just adapts, right? You can go back and forth. And this is what enables every single facet house to be completely unique. You also see the BIM model is layered with all this different information. So if we zoom into this junction here, we can see we've got structure, we've got different parts of the chassis, we've got the shading devices come in. You can even see there's buildup of the render on the outside. You can see there's connections all underneath that as well. So this is where we work out all of those really detailed junctions and resolve it here digitally before we actually build it physically. So as we're explaining, the model is a design tool, but it's also a technical tool as well. So through here, we're also resolving, the aspects of the layout, where the kitchen's going to go. You'll see the kitchen actually evolved from some of the early renders that you saw with Bruce in episode 1. So now we've resolved the kitchen as we have a more detailed plan of what it's actually going to look like at this stage. We can also work out really detailed aspects of where faucets go, particularly around bathrooms and the junctioning that you get from that. This is the online viewer that we've been experimenting, which is a program called Speckle, which allows us to upload the model into this online viewer. And as you can see, compared to viewing it in Revit, it's extremely lightweight. It's really quick to actually view things. You can also slice through the model. So yeah, here you can really quickly cut through the model, and you've still got all the same detail that we'd find in the BIM model, but it's just online, really quick and accessible for us to look at, whether we're on site or having a design discussion here in the office. It's just a really quick way to look through the model and share it. Yeah, we can also open up the Revit model using our visualization software, which is Enscape, and continue to walk around the model and review it from a design perspective. So as you can see, the model that you saw in episode 1, which Bruce was showing, the kitchen wasn't fully resolved, but now we have it in here. It's not textured in this model, but we can get a feel for what that space is now going to look like. So the model doesn't only get more rich in terms of technical information, but also design information. And we can continue to have these discussions with the client around the spaces within the house. So you can see this double height space is really going to be quite amazing, and continue to review different aspects, particularly as we get, I'll just fly through the building here into the more detailed aspects, particularly space like this where you've got the bathroom and you can actually start to see what the tiling is going to look like, the fixtures and fittings. At every stage, we're interacting with the client, both from the technical development, but also the design stages.
My name is Pedro. I am the head of production at Facit Homes, and I've been working for the company for 14 years. As head of production, I am in charge of the production of the chassis from the design stage up to manufacture, and I'm also in charge of research and development. The workflow to go from the BIM model to real life is what we call the D process. It involves putting into the BIM model the architectural design and also everything else that needs to be there for the building to work, like a structure, services like plumbing, ventilation, and electrics, and taking all that information, coordinating it so there are no clashes and everything works well, and putting that into our CAD/CAM system that then outputs things like G-code so we can control our machine and all our shop and construction drawings. The Facit chassis components are made of flat parts of plywood. Next thing is the CAM process that takes all those flat parts and lays them down into individual sheets of plywood in the best, most efficient way possible. This, in one hand, saves costs because it uses less material, and because it uses less material, is as well more sustainable. A router is a woodworking tool that uses a spinning blade to cut material, which is usually flat material, plywood, MDF, chipboard, or similar. And a CNC router is one of those tools, but it's controlled by a computer, which allows it to be very, very accurate. We take one of those CNC routers and put it into a shipping container, and that is the heart of our Microfactory, our MPF. Our CNC routers are accurate to 1/10 of a millimeter. Wisa plywood is an extraordinary material that has a great weight to strength ratio. It's very dimensionally stable and it machines really well.
Thank you once again for joining us on our Facit Homes channel and our Facit Build series. In this episode, we've covered everything now, essentially in the design stages up to RIBA stages 4. In our next episode, we're going to be actually on site looking at demolition, foundations, and even using a little bit of robotics in the foundation systems. If you are interested in building a home with us at Facit, please get in contact at info@facit-homes.com and you'll speak to myself or Bruce about your projects. You can also find out more on some of the other videos that we have on YouTube. If you like this episode, you can also help us grow the channel by simply liking and subscribing to the channel, or share it with anyone else that's thinking of building their dream house. Otherwise, we'll see you in our next episode where we're actually going to be boots on the ground on the site looking at how we build our foundations.